time complexity of deadlock detection algorithm for a system with m resource types and n process is. So we need to find out the time complexity of a deadlock detection algorithm where it contains m resource types and n process. So here any system can be identified the deadlocks using the deadlock detection algorithm when there is a cycle in the resource allocation graph. For example, if resource allocation graph contains m resource types, the number of resource types are m and the number of process are n. So n is the number of process. So in order to find out a cycle, we require to access the cycle detection algorithm. The cycle detection algorithm need to perform some operations in order to identify there is a cycle in the resource allocation graph. Usually it has to perform m into n square operations to find out a cycle. When there is a cycle, it is unsafe, it leads to deadlock. So like that we can detect the deadlock after invoking the cycle detection algorithm in a graph. Usually the cycle detection algorithm need to perform these many operations in order to find out. So that we need to have the complexities m into n square. So option A is correct. Order of m into n square is option A. Order of n into m square is option B. Order of mn is option C. Order of n square is option D. So option A is the correct option here.
A program segment is given and we have to find out the output of the program segment. Here A is declared as integer variable, and if we execute this program, because of the first printf statement, enter any character for A would be displayed on the screen, and if the user types character A, character 2, then character 2 would be returned to A because of this getChar. And as we have declared A as integer variable, ASCII value of character 2 would be stored in A. So because of second printf statement, ASCII value of decimal 2 would be printed, which is option C. The question is, queues serve a major role in first option, simulation of recursion, simulation of arbitrary linked lists, simulation of limited resource allocation, and expression evaluation. In simulation of recursion and expression evaluation, we use stack. So here Q is nowhere related to options A and D. So we can eliminate these two options. And if we see third option, that is option C, whenever there is a limited resource, we allocate that resource with the help of Q. Let us take one example. We know that more than one process can request a particular device at particular time, and we cannot allocate that device to more than one process at a time. So we resolve this issue by maintaining device queue for each and every device. We will allocate that particular device to one of the process, and we put the remaining process in the device queue. So these processes would be waiting to access that particular device in the device queue. Here the device is a limited resource, and we are using this device queue for allocating that particular limited resource. Hence here the correct option would be simulation of limited resource allocation. We have to find out the space complexity of merge sort. While sorting the elements, merge sort chooses one auxiliary array, that is extra storage for sorting the elements. This is the drawback of the merge sort. As the array contains n elements and it uses one extra array, the space complexity of the merge sort would be order of n, which is option A. Here a graph with 20 vertices is given, and we have to find the maximum possible number of edges in the graph. For the number of edges to be maximum in a graph, that graph should be complete graph. and here number of vertices is given as 20. So in order to get the maximum number of edges, the given graph should be complete graph. So the graph should be complete graph with 20 vertices. Complete graph with 20 vertices is represented by K20, and number of edges in Kn is equal to NC2. So here number of edges in K20 is equal to 20C2, which is 20 into 19 by 2 into 1. So number of edges would be 190, which is option C.
Let L1 be a CFL and L2 be a regular language, not necessarily finite. Then L1 minus L2 will be option A CFL, option B regular, option C context sensitive, option D DCFL. So here we have given with L1 is a context free language and L2 is a regular language, which is not necessarily be finite. That means it need not be finite always. Then L1 minus L2 will be, so here L1 minus L2 can be written as L1 intersection complement of L2. Anyway, L2 is given as a regular language. The complement of regular language is also regular. So here L1 minus L2, just I am writing it as L1 intersection complement of L2, because it is L1 and the strings not in L2. Not in L2 means it's a complement of L2. Complement of regular language is regular, so it will become intersection of one context free language and one regular language, because L2 complement is a regular language. So intersection of one context free language and one regular language, it is a CFL. It is CFL because it is not always finite. If it is infinite, for example, if L1 is equal to a power n b power n such that n greater than or equal to 0, it is a CFL but not regular. But L2 dash is given as, for example, a power n b power m such that n comma m greater than or equal to 0. So here the L1 intersection L2 complement, it is a power n b power n only, because all the strings of L1 are subset of given language. So a power n b power n is the resulting, which is also CFL. So option A is the correct option here. Consider the following statements. There were two statements given. S1 is the symmetric key cryptography requires n different keys to have a communication among n individual users. Statement S2 is digital signature provides authentication and non-repudiation but not provide confidentiality. Which one of the following statement is correct? So here options given are S1 is true and S2 is false, S1 is false and S2 is true, S1 and S2 both are false, D S1 and S2 are true. So here if you observe in the statement S1 saying that symmetric key cryptography requires n different keys to have a communication among n individual users. For example, let us suppose symmetric key means the source and destination will have to use the same key. For two users to communicate, one key is required. Then if n different users are communicating, then n keys are required is given, but for two users only one key is required. Originally it requires n into n minus 1 by 2 number of keys, because if you have three users, for example, so these two people will have one key, these two people will have one key, and these two people will have one key. So there are three keys, that is 3 into 3 minus 1 by 2, that is 3. When you use 4 users, for example, 4 into 3 by 2, total 6 keys are required. So for every pair we should have one common shared secret key in a symmetric cryptography. Okay, but that is statement S1 is false, because we require n into n minus 1 by 2 number of keys. S2, digital signature provides authentication and non-repudiation but not provide confidentiality. It is true, because digital signature means the source will encrypt the data. The source will encrypt the data with a private key of source that is not known to anybody. So the destination has to decrypt the data with a public key of source. When it is get opened, so it is a proper identification that the message is coming from proper source only. That is an authentication. Non-repudiation means the denial of service. The source cannot deny that I can't send a message because already it has been opened with source public key. So it might have been encrypted by source private key only. So that is why, so non-repudiation and authentication both are provided. Confidentiality is not provided because a confidentiality is required means the source has to encrypt the data with the destination public key. So that destination can open with only its private key. So now this message can be opened by anybody who knows the public key of source. So that is the reason it is not providing confidentiality, but it provides authentication and non-repudiation. So S1 is false and S2 is true. Option B is correct here.